This call is now being recorded.
Okay, so supervised learning is a task of performing classification, and for unsupervised learning, we do not have any reference. So what do? We cluster them based on the content of the document. Okay? But if you look back at the previous lecture, we have a few classifiers. So different classifier may perform differently according to the data that we give them. Okay, so one classifier may give them a class of 0, or the other classifier may give them a class of 1. This is assuming that we have a binary classification, 0 and 1. Okay. And today we will look into ensemble classifier. Ensemble means we are combining a few classifiers in order to improve the classification task. And we will also look at the feature selection, because feature selection affect the performance of the classifier. Okay? So we look into ensemble classifier first. So what happened in ensemble classifier? We combine prediction. Okay. So we combine prediction of distinct classifier. Okay, so several classifier will be combined in order to generate a new predictive score. So which means that we are getting the new predictive score based on a combination of several classifiers. So this is good because it can improve the classification because we have more than one classifier. And for this ensemble, we have two types. The way it depends on how you arrange the classifier. Okay? So we have stacking and we have boosting. So for this one, we will define both, but we will look into boosting in depth in order to look how we can apply this one in order to improve our classification. Okay? So we start with stacking based classifier. So remember that the keyword here is we are combining several classifiers to become a single model that can be used to improve the prediction. Okay? They are called ensemble classifier. So kita akan tengok the first one. This is called stacking base. Okay? So for the stacking base, what happened is that we will have a few classifier here. Okay? And we feed the same training data. And this is the prediction that they get. So if we, so this one means for every document, okay, for every document that we have, we will predict the class of the document using several classifiers. So this is document 1, this is document 2, and so on. Okay, so you may have a few documents here. So we will generate a new predictive score, this one, based on the majority of what produced by this several classifier. Okay, so if most of them give class 1, so the true class will be 1. So we will assign class 1 to document 1. So compared to this one also, this one, most of them give prediction of 0. So we will put the true class as 0. So we can do it for all the document that we have. So it could be 1 up to 100. Okay, so this is what we call the meta classifier because it's combined several classifier in order to produce the new prediction score for each document that we have. Okay. So in this one, in the stacking method, we learn function that combines prediction of individual classifier. So basically, we are looking at this. Okay. We try to learn a function that can map all this prediction to a new score, a new predictive score. Okay. So they will combine all the prediction of individual classifier. Okay, so with each document class pair in training set, we will try to associate prediction made by distinct classifier. So this is our distinct classifier. So what we will do is we will try to associate prediction made by distinct classifier. So we try to find this model. Okay. So the most common one, we look at the mode or the most occurrence of symbol that we have here. If most of them are 1, so we will give them 1 lah. Okay. So instead of predicting class of this one, so this is normally we do using a classifier, but in Ensemble, we predict the classifier that best predicts the class of document DJ. And then we combine the prediction of best classifier to produce better results. So this is what we call the best classifier. Okay? The best classifier. So in return, we will use the best classifier to form this what we call ensemble classifier, because we ensemble a few base classifier to form the meta classifier. Okay, so any question on this? So the advantage of using this type of classifier is that error of base classifier can be counterbalanced by hit of the others. So if we see one of them not performing well, at least we have other classifier that can counter balance the result, the final result of your prediction. Okay, so in a way that it improves the quality of the prediction or improve the accuracy of the prediction. Okay, so stacking. So this is what we call stacking lah. Okay, we stack the classifier on top of each other, and each one of them will get a copy of the test document that we have. Okay. We have the second one called boosting. So boosting, if you think about boosting, means we improve the accuracy stage by stage. So that's why we call it boosting. Okay? So in boosting, what happens is that given this is your data, this is your model, you train the model. Okay, so this model will give you the result. So together with the result and the output, and the input of the same input, we will try to focus the one that is misclassified. So instead of having the same data, we also get the input from the previous model. So they are in this sequence. Okay, so compared to stacking, stacking for each classifier, we have a copy of the document. Okay, and compared to boosting, you need to pass the result that you have from the first model and then use that information in the second model. And after performing the task in the second model, we use the output given by model number 2 to the third model. Okay, so what happened here is we will focus more on the misclassified training document, because when we get the result here, we know which one is correctly classified, and we know which one is misclassified. Okay? And the other keyword is that they are using the same learning technique, the same model here. If you're using model X, so all of this will use model X. If we compare with the stacking, you could have different model here. So we have support vector machine, naive Bayes, and k nearest neighbor. So in stacking, we use different classifier. In boosting, we use the same classifier. Okay? So at each iteration, each document in the training set is given a weightage. Okay, the weightage for incorrectly classified document is higher compared to the correctly classified. That means we are focusing more on the incorrect classifier. No, incorrectly classified document. Okay. So after n round, the output of the trained classifier are combined in a weighted sum. We will show you this one, how we get the summation of all the weightage. Okay. But the idea is we get one input, one document, and then we feed into this model X. So whatever information we get here, especially the one that correctly classified document and incorrectly classified document. Okay. So when the second model get the input here, it will classify it again, and it will produce the same output here, and so on. So I will show you the sequence here. Okay, so this is the boosting based classifier, ada boost algorithm. In this case, in this algorithm, what happened is that we get a training set function. So the training set function here contain all the document that we have, and also the class, the class label. And also we know the number of training, that the number of training document, and M refer to how many times you want to go over. Like for this one, this is M equal to 3 because we process them 3 times. Okay, we have 3 level of boost. So this M refer to the number of iteration. Number of iteration means how many times you want to use the same classifier to process the document. Okay, and given the document that we have, we will initialize the weightage of each document to be 1 over NT. So if we have 10 documents, we will normalize the weightage to be 1 over 10. Okay, so this is the initial weightage of each document. So next one is we will go from 1 to M, which means that we will repeat 1 to M. So it depends on what is the value of M. in the example previously, m equal to 3. Okay. So our task is to learn the classifier function from the training set. So this is the process. So the first thing that you need to do is you need to estimate the weightage error, how many documents that incorrectly classified. Okay. So we will take the weightage that we assigned previously, okay, and how many of them are incorrectly classified, and then this is the error. So the error depends on the summation of all the incorrectly classified document. Okay. Okay, once we get the error here, so we will plug in here. So this is the classifier weight. So this is how we find them. So this is constant 0.5 times log. Normally we use the natural log. So 1 over the error that we find here divided by the error. Okay. Okay, so once we find this, the classifier weightage, so the classifier weightage could be, we are looking at this model, this is all classifier. So maybe this is 0.9, this is 0.3, this is 0.65. So this is the weightage that we are looking at. We try to find the weightage of each of the model depending on how many number of document that is correctly classified here. Okay, so I will show you the example. And then these two are the way on how we can increase the weightage. So for example, we want to focus more on the incorrectly classified example. So incorrectly classified, so which means that we will add this value. Incorrectly classified example, we want to tambah the weight because we want to focus on that particular example. And for the correctly classified example, we have to reduce the weightage. Okay. So if you look at the algorithm here, it is a bit difficult to visualize. Let me bring you to the next slide. Okay. Okay, let's suppose we have this search space. In this case, we have 10 documents. So we have 10 documents. And the symbol tell you the class that they belong to. Okay, so we have 5 positive and 5 negative. Okay. So the weightage will be 1 over 10 because we have 10 documents. So we will assign each one of them 0.1. Okay, so 0.1. So this is the first setup that you need to do. You need to compute how many documents that we are talking about. So in this example, we have 10 documents. So the weightage will be 1 over 10 here. So we will assign this weightage to each of the document that we have. Okay. Okay. Let's suppose we using a classifier. So the classifier tell you that I will divide my search space into positive here and negative here. Okay. So if you notice that we have 3 incorrectly classified documents, which is these 3. They are supposed to be on the other side here, because everything on your left here will be positive, and everything on your right here will be negative. So we assume these 3 are incorrectly classified. So what is the error weightage? So we just add up this value. So we get 3.3. Okay. And this is the error weightage. So what we need to do next is we want to find out the weightage of the classifier. So the weightage of the classifier is just performing this formula calculation. So we have 0.5 times natural log 1 minus the error that we have here divided by the error. So we have this. So the value 0.42 here is referring to the weightage of the classifier that divide this search space. Okay, so we will use that one later on. Okay, okay. Let's suppose the next one is because we have these three which is misclassified, we want to increase the weightage for this one. And the remaining 7, we want to decrease the weightage. So what happened? How do we? So this is the formula for the correct one. So if you look at the formula here, so for the correctly classified example, we need to multiply the weightage with the exponential to the power of minus the error here. No, the classifier weightage. So the value for this one is 0.66 and the value for the incorrect one will be 1.52. So what happened? We take this value, multiply with this 0.1. Remember that this is only for the correctly classified one. Okay, and for this one, incorrectly classified, we are looking at this, the big one. Okay, so we multiply that value. That is the formula. So that's how we get this number. So this number is basically 0.1 times 1.52. Okay. So from this transition, from here to here, basically we are putting more weightage on the misclassified document, or we call it incorrectly classified document. Okay. So before we move on to the next iteration, we need to normalize all these values. So what we will do, we will add up all this value. Let me erase this one first. Yeah. So we add up all this value, and then to normalize this, each of the weightage, we will divide them by the sum of all this value. Okay. For example, to normalize this, we have to divide them by 0.918. So this is the value of all this. This is the value 0.18. Okay, so to normalize this, we just divide by 0.918. So this is the new value that we get after we normalize them. The same thing goes to the other. So this is only round 1. So round 1 means we only completed this one. Just one stage here. Okay, so round 1 is only up to here. So this is round 1. Okay, complete round 1. So next iteration, we take this value. Okay, we take this value and we use the second classifier. Okay, the second classifier, tell you that whatever on your left will be positive, whatever on your right will be negative. Okay? So if you ask me, how do I know that the partition is there? The partition is given. Okay? So what you need to do is you need to determine which document are incorrectly classified. Okay? So for example, like this, we have 3 documents again misclassified, which is 1, 2, and 3. Okay. So the number of the weightage, the summation of weightage for all misclassified will be, you just add up those 3 numbers, then we get this. And then we get the weightage of the classifier, which is 0.65. So this is obtained by getting the nil. So this is 1 minus 0.21. This is divided by 0.21. So we get this. Okay. So this one is actually the weightage for this classifier, 0.65. Okay. So to adjust the weight, we do the same thing here. So we get this exponential to the power of minus 0.65. So we get this value, and then we multiply with the correct one is this one. Okay. So the incorrect one, we just multiply with these 3. So that's how we get this number. Okay. So before we proceed, we have to normalize this value. So we add up all this value, and it turned out to be 0.829. So what happened is we take this number 0.037 divided by 0.829. Then we get this value. Okay. Okay. So this is the end of round 2. And so the next one is we take this value and given a classifier that tell us this one. So everything to the top is positive, everything to the bottom is negative. So based on this observation, we have 3 incorrectly classified documents. So what do? We add up them together and we get this value. So we find the weightage of the classifier that divide this search space. So this is the weightage. Okay. Okay. So since we only got through 3 times, so we only have 3 weightage of the classifier. So this is from the first one, this is from the second one, this is from the third one. So if you combine all these, so the area that we have will be something like this. Okay. So if you want to test a new one here. So if you want to test the X here, so what we need to do is we just plug in the value here. So since X is in the minus territory, so X here, and then X here, and then X. So we have -1, this is +1, this is -1. So we just plug in those values here. Okay. And the sign that we have is -0.69. So since the value is negative, so we assign this to be negative value. No, negative plus. Okay, similar to Y. So if we have Y, Y here is negative, Y here is positive, and y here is positive. So if you plug in the number here to the function, so we get 1.15. So the sign is positive. Thus, we assign this one as positive class. Okay. So this is the example, some of the example for your final exam. Okay. Any question? If you okay, can you type number 1? So this lecture is a bit difficult to understand if you listen to the lecture for the first time. But try to do the assignment. I hope the assignment can be used as a training session for you for the final exam. Okay.